On day 4 of this unit, Bethany begins by having her students develop criteria for what counts as a strong hypothesis. This is still the beginning of the school year, and she wants to get her students used to talk about evidence and logic. During this class, you can hear Bethany and her students laying the groundwork for future conversations that have all the characteristics of scientific argument. Bethany starts off by asking students to think privately for a few minutes in a warm-up about what might make a reasonable hypothesis. This prepares students to contribute more readily in whole class conversation.
What ones would you use, or which ones could you put together? Yeah.
Said provide examples and supported by strong evidence.
Okay, so providing examples and supported by evidence go together.
Yeah, because you need, like, if you have a hypothesis, you have to have a reason to back it up, or you have to have something to back it up.
All right. So these two can go together. And then Jasmine, you wrote this one, providing examples. So can you talk a little bit about what you meant by providing examples?
Like you can provide ways to test your hypothesis and like examples on how it connects to.
So we can kind of interpret this provide examples different ways. We can interpret it as like provide evidence for it, but also connect it to like what we think makes sense. And so I feel like these are all kind of a web of things that work together. And so what I want to show you is a list of 3 things that we can use to evaluate a hypothesis. But I want to see if any of your ideas are missing from this list, because these are just 3. We can come up with a 4th one if we need to. So let's take a look at these 3 features of strong hypothesis. And I think elements of everything you said are included in these, but tell me if something is missing. All right. So the likelihood test. How likely is it that the events in your hypothesis can actually occur? Are there parts of your hypothesis that depend on really unlikely things happening? So this goes with what over here? Makes sense and it can be true. Is that on here? Oh, it can be true. So I think this person, when they said that it can be true, they meant like I could believe it. It's likely that it could happen. Okay, how about this? Fits with all data patterns. Can the hypothesis explain most or all data patterns? Yeah. Which does, well, first let's see if we were missing anything. What does it go with? This one. Supported by strong evidence. What else? Anything? There's an idea that didn't get up here. I don't think you wrote yours down, but we talked about how what you were thinking about for the graph, the 35-year graph. So you said to be a good hypothesis, it has to
fit the data.
Fit the data. So not only like can you support it with data, but it has to fit the data that exists. So you have to be able to use it to explain the data that we have. So he's thinking about one of the scenarios, and he's thinking it doesn't match with the big graph, and so it's harder for him to think of it as a strong hypothesis, even though it probably does have evidence to support it. So anybody see something that's missing from here, that's on here, or in your head? Moises, I know you have one that you could share. Okay, so this idea here. Okay, so could you say a little bit more about it, about that idea for the class so we can add it to our chart here? Fits with all data patterns?
Yeah.
So you think it does fit it or it doesn't? Because I saw you just nod your head, but let's hear what Cecilia says.
Because I think that the data is basically your evidence. Because that's what's given to you, that's the stats that are given to you, and that's what you put in to describe your evidence, and that's your because.
Okay. Like there's something to be said for you want to know if you can trust the evidence. Did the person who collected the evidence do a good job collecting that evidence? Is that kind of what you're thinking too? Like, was the evidence actually good quality evidence?
Do you mean like the evidence that was given to us? Like, was it, like, just the evidence. Oh, so is the evidence like? I don't know what the word is, but I think I know what you're trying to say.
Well, I'm trying to understand what you all are trying to say because I saw this idea a lot. And I think when you say that, you're thinking something different than the fact that it fits with the big scale. Like, so this is like, does it fit with the big graph does it match with the bigger picture? But I think that a lot of you have this idea about the evidence needing to be good evidence. So, I think I'm gonna just leave it at that right now, and you can discuss it at your table as you think about your hypothesis. And maybe we can figure out more about what this means to you, but I think you all think that it has to be good, strong evidence, and we'll think about what that means. So what I'd like you to do is make sure that you have these four things written down, 4 features of a strong hypothesis. And you're going to go with your group and discuss which features of the strong hypothesis your group's hypothesis has, and write them in your journal, and then choose which group's hypothesis seems to be stronger. So at the end of class yesterday, we had 3 or 4 different ideas about the strongest hypothesis in the class. Some people thought Moises's, some people thought Lysiana's, some people thought Wallace's, and I think there was one more that people thought was the strongest one. So I'm just going to take 10 minutes in your group to discuss these 2 questions.
We can talk about like what features our hypothesis has of the 4 features.
4 features? There's food. One of them.
So like, does it have like the likelihood test, which is like how likely like the events occur, or if it depends on unlikely things happening?
It's actually likely to happen.
Huh?
It's actually likely to happen.
Okay.
Like food increasing.
And like it fits with all the data patterns. I don't think ours fits with the 35-year one though.
Well, yeah.
I don't know, because would it just be like, it would just repeat, it would just, the food increasing and decreasing? Because yesterday, like Wallace asked me, he was like, how does the food just keep, like all of a sudden has like a big increase, like did the food just like fall from the sky, or like,
Well, Mother Nature, you know.
I don't know, but,
Then there's the climate change. The climate can change every time.
but we didn't talk about that.
Oh, yes. Oh, I did.
And then, is it based on known science, which, do we use our background knowledge?
Does it fit the data pattern? Like,
They kind of did, but like Moses' group, his fit the data pattern.
Moses?
Yeah,
What was his?
Moses.
What was his?
Oh, he said that the predators, like, it increased because the predators weren't hunting as much, and then it decreased because the coyotes started migrating and hunting more.
Yeah, I didn't understand that part. Like, why would they keep migrating back?
Likely?
Yeah.
Or the most? Yeah.
Michelle didn't make sense, so I don't know.
Alright, well let's explain to him what Michelle and Wallace said.
So,
What are your notes? Which one is it?
we named it differently, but it's still the same group. So, what Alyssa told me was that when the chart goes like that up and down pattern, I don't have it on it, but when it goes the up and down pattern, when it goes up, that's when like there's no hunting season, nothing's going bad. Like sure, some of them are dying, but it's fine. But then when it goes down, that's like hunting season. Like you know how people go out to kill things? That would be hunting season. Then it goes back up and then down. And she said like even though some hunting seasons are like every year, there could be some places where it's only every couple of years, so that they don't kill off too much wildlife.
What do you think about that?
But I think it wouldn't really make that much sense every 11 years. I'm pretty sure it at least has to be every more often than that.
So which,
So which criteria does it not necessarily match with? The likelihood?
Yeah.
Okay. So you're saying that that's not the strongest because it doesn't match the.
It's not so likely.
So which one did you hear yesterday that you think is pretty likely?
That was pretty close, but then just saying that it doesn't really like sound right on the ear. Like that's kind of season part.
Okay, so that's actually maybe goes with the third one of like how it matches with your knowledge of how things work.
And also hearing like other people's hypothesis, it kind of like persuaded me, like changed my mind about.
Okay, and what persuaded you? Which one are you going with?
Like, because I don't think food is the problem anymore. I think it's predators. Yeah.
We were talking about food, though. We were like, there was like a couple flaws in his hypothesis, so then that's when we were debating about it, because I was arguing with him.
Oh yeah, then I agree with him.
I remember
It
that.
wasn't like, well, like it didn't have like strong evidence to back it up, and it didn't fit in place. So, yeah.
Didn't fit the data.
So my group, the 3 features of a strong hypothesis. So basically we just looked at the first one, and then we looked at all the tables, and we eliminated the ones that didn't fit it, and then we just went down the list.
So did you find any that fit all 3?
No, we didn't get there yet, but we had like 3 left.
Okay. So you kind of had eliminated, you took only the ones that were likely, and then you went, eliminated from that only the ones that fit the data.
And then we were like, and then we were deciding between the 3.
All right, and did you keep your own?
Yeah.
Because
It fit everything.
Okay, good. So we're going to continue thinking about these, but it's pretty complicated, and I agree that we need to get more evidence and think about where that evidence came from. We also need to think about some specific parts of your explanation. I think if we break it down and look at the parts of this system, it's going to help us think about causes and effects and kind of the bigger picture. And so we're going to today work on making a model of this ecosystem. And we're going to do this kind of system for drawing it. So first, all of the components of the system, you're going to label them. And a component is a part of a system. So if we think about this ecosystem, we're going to talk about the parts of it, the components, and how they affect each other. Okay, and so we're going to use an arrow like this to represent something that has a positive effect. And we're going to use an arrow like this to represent something that has a negative effect. So if you could write those 2 things down. So I'm going to show you some examples of connections that you might make in your model. All right, so you might have 2 things in your model like this, 1 and 2, and these would be labeled, so maybe this is something else. This one is having a positive effect on this one. Is this one affecting this one at all?
No.
How do you know?
Because there's no arrow pointing that.
No arrow pointing this one, that way. So 1 has a positive effect on 2. Yes, please. All right. So, Elpidio, do you agree that this is the best way to represent a human, the relationship between a human and a plant? Cecilia said that, that this one is the best way to represent a human with a plant. That they're positive for each other if the human's eating the plant. Okay. Why?
No.
Okay. Does anybody see a different one on here? If number 1 is the human and 2 is the plant, and you're eating the plant, that could represent that?
The one on the bottom.
Why?
No, up. There you go.
Okay, why?
Because you're eating the plant, but you're getting energy.
So why? How does that show that here?
It's bad for the plant because you're eating it, but
Okay.
you're getting the energy.
Okay, so the human's getting a positive effect by eating the plant. They're getting the energy, but they're eating the plant, so it's actually negative for the plant.
Yep.
Okay.
Because now it's dead.
Okay. And then underneath the connection, explain why. So like when Cecilia was explaining, or when Cecilia and Elpidio were explaining why they chose the connection they did, that's what I want you to try to do.
Someone took the coyotes.
What is the connection between this hare and the coyote?
This is great.
Okay, so how would you describe the relationship between them?
The hare is positive to the coyote, but the coyote is negative to the hare.
Because
Because the hare is eaten by the coyote, but then it's dead.
okay. Which one is positive? Which one is negative?
The coyote is positive and this one is negative.
Because
But they need food to eat.
so which direction is the arrow gonna point?
This one is positive and this one is negative.
Okay. And so Cecilia said it's because it eats it, but I heard Cecilia earlier talking about like a deeper why, so it's not just like what happens, but like why is it positive and negative?
Oh, because this is is making the population decrease.
Okay. And what else, Susanna? Why is it positive for the
Oh, because it's getting energy.
So I want you to explain as much as you can about why you think that relationship is positive or negative. Okay.
All right.
So it'll have a bad effect on it because they will start to die because they don't have no food. And then so this one it will affect that because they're still gonna be killing them. It's just that they won't have food. So it's kind of both bad for both of them.
The arrows from here. So it's positive and then
Why is it positive?
And then if it's got a dot, that means it's a negative.
So I want you to
But now I have a question. So you're saying that there's two predators, right? There's a coyote and a lynx. So what might be the relationship between the coyote and the lynx?
they're in competition.
Yeah.
So negative. Which one of those relationships would you say?
Oh, interesting. Would it be negative and negative?
Just big one. 0.
Because, yeah, as they eat more food, they take food away from each other. Oh, interesting.
All right, so tell me about what you have so far.
I think that's the coyote. So the hare is good for the coyote because and the lynx because they eat the hare. So these are bad for the hare too.
Yeah, take your planner.
And then these are bad for each other because they're in competition for like the food source. So that's why we have the green dot.
Okay.
And then these are good for the poacher, but like the poacher's bad for them because they kill them. And then indirectly, he's good for the hare because he kills the hare's predators.
Okay, so this is a kind of a model to show your whole hypothesis.
Yeah.
Okay, so what I want then is for you to label on the lines what it's showing.
Should we get another marker?
Oh, great. No, it's really great.
By the end of class, students had created a variety of models. These artifacts are created for 3 reasons: to make their thinking visible, to show students where there might be gaps in their thinking about the anchoring event, and to be added to or revised as they learn more. These are what make modeling a scientific practice.